Ever tried translating like something really complex with those AI translators and talk about like legal jargon, you know? A few years back, you would have gotten pure gibberish back. But these days, it's kind of freaky how good they are. And get this, the tech behind that almost magical translation. That's what we're diving into today. We've got excerpts from this academic paper, Neural Machine Translation, which, full disclosure, is pretty dense. But hey, that's why you're here, right? By the end of this deep dive, we'll break it all down. Not just what the tech does, but the crazy, clever ideas that make it work, even if you don't speak algorithm.
What's amazing about this paper is it totally revolutionized everything. Before this came out, machine translation was stuck basically trying to translate word for word like a very literal person with a dictionary. These old systems, they relied on statistics, they looked at tons of text and tried to figure out, okay, this word in this language, what's it usually paired with in that other language,
Right.
just based on how often they'd seen them together before.
So it's all about probability, like playing the odds with language. But I mean, anyone who used Google Translate back in the day knows how often that went wrong.
Oh, totally. Because languages are way more complex than just swapping words. There's context, grammar rules that change all the time. It's like a puzzle, not just a code to crack. And the people behind this paper, they got that. They knew the old statistical methods. They just couldn't handle how sentences actually work, especially across different languages, so they came up with something totally different.
And that's where this RNN search thing comes in. Sounds kind of like a secret code name.
It does, doesn't it? RNN Search is this brand new architecture they made. It tackled the weaknesses of those old models head on, a total game changer.
Okay, so huge deal. But they go deeper than just new thing good, right? There's this part that really got me, this soft alignment thing. Even the name sounds cool. Like the AI isn't just matching up words blindly. It's got this deeper understanding of how they connect, almost like it's paying more attention to some parts of the sentence.
Exactly. That's what makes soft alignment so groundbreaking. It's like
Yeah.
the AI is thinking, wait, this word over here actually changes how I translate that word way back there.
Yeah.
It's mimicking how we as humans just get the context of a sentence.
So instead of a robot with a dictionary, it's starting to think more like a human translator who understands all the subtleties. That's amazing.
Exactly. And the paper gives this great example, translating the man into French. Sounds simple, right?
Yeah.
But in French, the, whether it's le or la, depends on if the noun is masculine or feminine.
Ah, okay, I see where this is going. It's those little language quirks that can really mess up a rigid translation system.
Exactly. Word for word, it might just default to le, the most common form, and you get le which is wrong. But soft alignment lets the AI go, hold on, that word man, which tells us the gender, is coming up, so I need lum instead.
So it's like the AI is looking ahead, getting the whole picture before it commits. Way smarter than just guessing.
Exactly. And what's cool is they actually show this visually in the paper, figure 3. It's like a heat map. It shows the connections the AI makes between English words and their French counterparts. You literally see how it focuses on different parts of the sentence, just like a human would.
Okay, so we're seeing the AI like flex its context muscles, which is amazing in itself. But how does it actually get that deeper understanding? The paper mentions these burr-in ends. Kind of sounds like something from Star Wars, honestly.
It does, right? But it's not as complicated as it sounds. BRN stands for Bidirectional Recurrent Neural Network. Okay, imagine you're reading a sentence, but somehow you can read it forward and backward at the same time. Your brain is processing both simultaneously. That's basically a BRN. There's a forward RNN, reading normally, and a backward RNN in reverse. Gives it this much richer understanding of how every single word fits in.
So, like, giving the AI two sets of eyes, one looking ahead, one back, to really get the whole picture makes sense because one word can mean totally different things depending what's around it.
Exactly. And this two-way reading, it ties right back into that soft alignment we talked about. Remember how the AI figures out which parts to focus on more? The decoder, the part actually making the translation, it uses the context from the burn-in to choose. Like the burn-in is saying, hey, pay attention to this bit over here. It's more important than you think.
Ah, so that's how it clicks. The burn-in gives the AI that superpower, understanding context. And then soft alignment is how it uses that power to get the translation just right. Like a dynamic duo working behind the scenes, making everything smooth.
Perfect analogy. And that combo, that's what lets it handle these long, complicated sentences that used to trip up older systems.
It's kind of wild when you think about how much brain power, so to speak, goes into something we take for granted, like hitting translate.
Right. And it's all thanks to these algorithms and tons of data. Because remember, these AI don't just know how to translate, they have to be trained on a huge scale.
That's right. The paper mentioned using millions of sentence pairs to train it. millions. Where do they even find that much translated text? It's not like there's this giant library of perfectly matched sentences just lying around.
That's the thing. Getting that data is a huge task. Researchers use existing translations, subtitles, documents from global organizations, even books translated into different languages.
Tapping into what's already out there. But even then, it must be a ton of work to make sure it's all good, consistent, ready for the AI to learn from.
Oh, absolutely. Think of it like this: if you're teaching someone a new language, but only gave them bad grammar examples, they'd probably learn it wrong, right?
Good point. The input, that's what determines the output.
Exactly. So researchers spend loads of time cleaning this data, making sure translations are accurate, no inconsistencies, so the AI learns from the best.
Like making a gourmet meal for a supercomputer.
Yeah,
Top-notch ingredients for the best results.
I like that. And that's why this data prep, it's a hot topic in AI research. Better data, better AI.
It makes you realize, even with all the fancy algorithms, having the right data is still key.
Totally. Garbage in, garbage out, as they say. Especially with something as nuanced as language.
Okay, so we've got these powerful algorithms, massive data sets, tons of cleaning. But how does the AI actually learn from it all? The paper mentions this mini-batch stochastic gradient descent, SGD for short, anything like it sounds.
Honestly, it's simpler than it sounds. Imagine you're perfecting a cookie recipe. You bake a batch, try one, and tweak things based on what you taste. Maybe a bit more sugar or bake it a minute less. And you repeat, small batches, tweaking each time till you get it perfect. SGD is similar, but instead of cookies, it's equations representing how the AI understands language. It processes data in batches, making tiny changes to those equations each time to improve the translations.
So like fine-tuning a recipe but for language? Instead of flour and sugar, it's these mathematical things based on how well it's translating. Starting to see how it all fits together.
That's it. It's about finding the best settings for those parameters, the ones that let the AI translate new sentences it's never even seen.
Okay, so we've got a soft alignment for context, the BERNNs for that two-way reading, massive data, and SGD for fine-tuning. But there was one more term, beam search. Sounds kind of mysterious, like something a detective would use.
Uh-huh. I like that. Basically, beam search is how the AI picks the absolute best translation out of all the possibilities. Remember, it's all about probabilities, figuring out the likelihood of different words. It's like navigating a maze. Instead of trying every path, beam search has a flashlight, showing the most promising routes at each turn. It strategically chooses which way to go, getting to the right translation without wasting time on dead ends.
So working smarter, not harder.
Yeah.
Focusing on the best options, making the whole thing way more efficient.
Precisely. And that efficiency is key because with millions of sentences and countless word combinations, things could get messy fast.
Like having a really, really good editor who picks the most elegant, accurate phrasing. It's not just about the message, it's how it's said.
Exactly. And that's what makes this research so cool. It's not just about higher scores. It's about AI translations that sound human, natural, enjoyable to read.
It really makes you think,
Right.
all that complexity just to make something we use every day work. But this paper's about more than just the tech, isn't it? It's about what this tech can actually do.
Yeah, for sure. This wasn't just some theoretical thing. They actually showed RNN search, this new system. It beat the older methods, especially on those really long, complex sentences that used to confuse AI translators.
So no more clunky translations, the ones that just sound robotic and miss all the nuance. Exactly. And this paper, it was a huge leap forward. It really opened the door for a ton of new research into even smarter AI translation. And we're seeing the results now, right? I mean, think about how much better these translators are now than just a few years ago.
It's crazy.
It's not just about getting the words right anymore either. This research pushed things to make them sound more natural, more fluent, more human.
Like the difference between a textbook and actually talking to someone.
Mhm.
But even with all this progress, there's got to be limits, right? The paper mentioned something about rare words being tricky.
Right, and that gets at a big challenge in AI, and not just for translation. You can feed these things all the data in the world, but they'll still run into words they've never seen. Especially those super specific terms, like in technical stuff or specialized fields.
Like trying to teach someone a language, but only giving them so many words. They can handle the basics, but anything complex, they're lost.
That's it. And that's why researchers are always working on how these models deal with those out-of-vocabulary words, trying to help them make smart guesses from the context, kind of like how we use grammar and stuff to figure out unfamiliar words.
So it's not just about knowing a bunch of words, it's about understanding how language itself works.
Exactly. teaching the AI to think more like, well, a linguist. Someone who can analyze a sentence, its structure, the whole context, to understand the meaning, even with new words.
Wild. But what's even cooler is thinking about what all this means going forward. I mean, imagine AI translation that's so good, so natural sounding. What does that do to the world?
That's the big question, right? Imagine a world where language isn't this barrier anymore, where you can understand anyone, work with anyone, read anything, watch anything, without needing a human translator.
That's like something from sci-fi.
It is, but it also makes you think about jobs, education, how we communicate with each other and the world around us.
It really does.
And that's why it's so important to be having these conversations, to really think about the ethics of this tech, to make sure we're using it to benefit everyone.
It's like a reminder that even the coolest tech is only as good as the people behind it, which is something we should all be thinking about with AI, especially as it keeps advancing. So next time you hit that translate button, remember it's not just a tool, it's a glimpse into the future of language itself. And that future is full of amazing possibilities and some pretty big questions too. And as always, keep diving deeper, because the more we learn, the more we realize how much more there is to uncover.